This episode is brought to you by Cisco Educational Premium. Do you know that the equations of motion describe the behavior of a physical system? In physics, equation of motion describe the behavior of a physical system in terms of its motion as a function of time. The functions are defined in a Euclidean space in classical mechanics, but are replaced by curved spaces in relativity. Did you know that the first equation of motion is v is equal to u plus at? How do we derive this equation? When we rearrange the equation for acceleration a is equal to v minus u on t, and then we make v the subject with the formula, we get v is equal to u plus at, our equation of motion. Did you know that we can derive the first equation of motion using calculus? We know that the formula for acceleration is a dv dt. So rearranging this, we get a dt is equal to dv. Then after integrating both sides, we get integral from 0 to t a dt is equivalent to integral from mu to v dv, which equals at is equal to u is equal to v minus u. Then rearranging, we get our first equation of motion, v is equal to u plus at. Did you know that we can derive the first equation of motion by graphical method? Say we have the velocity time graph for a moving object with initial velocity u and final velocity v, and the acceleration a as shown. From our graph, the velocity of a body changes from a to b in time t at a uniform rate. You can also see that bc is the final velocity and oc is the total time t. A perpendicular is drawn from b to oc. A parallel line is drawn from a to d, and another perpendicular is drawn from b to oe, as shown by the dotted lines, those dotted lines. We can see that initial velocity u is equivalent to oa and the final velocity v is equivalent to bc. Also, bc is equivalent to bd plus oc. Therefore, v is equal to bd plus dc, and also v is equal to bd plus oa, since of course dc is equivalent to oa. And so we have v to be equivalent to bd plus u, since oa is equivalent to u. Let us call this our equation 1. Since the slope of the velocity time graph is equal to the acceleration a, we have a to be equivalent to the slope of line AB, which is equivalent to BD on AD. And so since AD is equivalent to AC is equivalent to T, the above equation becomes BD, which is equivalent to AT. Let us call this our equation 2, shall we? Now, finally combining those two equations, we get V is equivalent to U plus AT, which is our first equation of motion. Did you know the second equation of motion is S is equal to ut plus half at square? How do we derive this? From the first equation of motion, V is equal to u plus at. We know that S is u plus v on 2 times t for linear systems where velocity is not constant. Then substituting the value of v from the first equation of motion, we get S is equivalent to u to bracket u plus at bracket, then close the bigger bracket on 2 times t, which is equivalent to 2u plus at times t on 2, which is also equivalent to 2u on 2 plus at on 2 times t, which is equivalent to bracket u plus half at bracket times t. Making further simplification and cleaning this, we get the equation S is equivalent to UT plus half AT square. Did you know that we can derive the second equation of motion using calculus method? Mathematically, we can have velocity v to be ds on dt, and rearranging this we get ds is equivalent to v dt. Then substituting the first equation of motion to this we get ds is equivalent to bracket u plus at bracket dt, which is equivalent to bracket u plus at dt, which is equivalent to bracket u dt plus at dt bracket. Integrating both sides, we get integral from 0 to s ds is equivalent to integral from 0 to 2 u dt plus integral from 0 to t at dt is equivalent to s is equal to ut plus half at square. Our second equation of motion. Did you know that we can derive the second equation using graphical method? Say we have the velocity time graph as shown there. Using our graph, we can do some deductions. Distance traveled S is equivalent to the area of the figure OABC, which is equivalent to the area of rectangle OADC plus the area of the triangle ABD. And so, S is equivalent to half times AD times BD plus OA plus bracket OA plus OC bracket. Since OA is equivalent to U and OC is equivalent to T, we get this equation as S is equivalent to bracket half times AD times BD bracket plus bracket U times T bracket. We know that the BD is equivalent to AT, so the equation becomes S is equivalent to half times T times AT plus UT. And doing some simplification and cleanup, we get our second equation of motion S is equivalent to UT plus half AT square. Did you know that that equation of motion is v square plus u square plus 2as? We can derive this equation by algebraic method. Mathematically, we know that displacement is equivalent to initial velocity plus final velocity on 2. So we have s is equivalent to u plus v on 2 times t. From the first equation of motion, we have v is equivalent to u plus at. So rearranging the above formula, we get t is equivalent to v minus u on a. Now, substituting t in the displacement formula, we get s is equivalent to v plus u on 2, v plus u on a, is equivalent to v square minus u square on 2a. So then we get 2as is equivalent to v square minus u square. And rearranging, doing some cleanup, we get v square is equivalent to u square plus 2as. Did you know that the third equation of motion can be derived from calculus? We know that acceleration is the rate of change in velocity and can be written as a is equivalent to dv dt. Let us call this our equation 1. We also know that velocity is the rate of change of displacement and can be expressed as v is equivalent to ds on dt. Let us call this our equation 2. So it follows that we cross multiply our two equations. We get a ds on dt is equivalent to v dv on dt. And so integrating from 0 to s a ds, it will be equivalent to integral from u to v dv. We will obtain the result as v square minus u on 2. Then doing some rearrangement, we get v square is equivalent to u square plus 2as. Our third equation of motion, by the way. At times you are getting an answer and you already forgotten the question. Did you know that we can derive the third equation of motion by a graphical method? Take a look at the velocity time graph. Our graph has all the information we require. And so we know that the total distance traveled S is given by the area of the trapezium OABZ. Therefore, S is equivalent to half sum of parallel sides times height, which is equivalent to half times bracket OA plus CB bracket times OC. Since we know that OA is equivalent to U, CB is equivalent to V, and OC is equivalent to T. The equation thus become S is equivalent to half times bracket U plus V times T, and since T is equivalent to bracket V minus U on A, the above equation can be written as S is equivalent to half times bracket V plus U bracket times bracket V minus U on A, which is equivalent to V square minus U square on 2A. Then engaging the brain just a little bit and solving this, we get our third equation of motion. V square is equivalent to U square plus 2AS.